Hello students, welcome to today's lesson on salt. Let us begin the lesson by asking, what are salts? Salts are ionic compounds. And how do we make salts? There are four common ways to make salts. First, we have acid reacting with metal to give you salt and hydrogen gas. Second, we have acid reacting with carbonate to give you salt, water, and carbon dioxide gas. Third, we have acid reacting with base to give you salt and water. Lastly, we have acid reacting with alkali to give you salt and water. Next, we move on to the fundamental concept of salt, which is to understand the solubility of salts. Let us look at the solubility table. It is broken down into two columns. On the left, we have the soluble salts, and on the right, we have the insoluble salts. For soluble salts, we have all sodium, potassium, ammonium, and nitrate salts. These are also known as sparse salts, with the exception of nitrates. Next, we have chlorides and sulfate. All chloride salts are soluble, with the exception of silver chloride and lead-2 chloride. For sulfate, all sulfates are soluble, with the exception of barium sulfate, lead-2 sulfate, and calcium sulfate. So, how do we remember them? Let us make use of this ABC method. First of all, we know that chloride starts with C and comes before S for sulfate. Next, we have ABC, where A stands for AgCl, which is silver chloride. B stands for barium sulfate. C stands for calcium sulfate. So this will form the A, B, C for chlorides and sulfate. In both chloride and sulfate, insoluble salts will have lead-2 salts. Lastly, we have our carbonates. All carbonates are insoluble salt, with the exception of sodium, potassium, ammonium, which are our sparse salts. So this is one simple method to remember your solubility table. So why is solubility of salts important? First, it tells you the state symbol of the salt. Second is to determine the preparation method. So we look at the first item. So for example, what is the state symbol of the following salts? We have sodium chloride. By looking at the solubility table, we know that sodium chloride is soluble and therefore it is in aqueous state. Next, we have barium sulfate. By looking at the solubility table, we know that barium sulfate is insoluble and therefore it is in solid state. Next, we move on to determine the preparation method. So we look at this example on how can we prepare barium sulfate. We can follow these four simple steps. Step 1 is to determine the state symbol of the salt. Step 2 is to select the suitable preparation method. Step 3 is to identify possible reactions. And step 4 is to identify the reactants. So in step 1, since barium sulfate is insoluble in water, it is in solid state. In step 2, if the salt is soluble, it is prepared by reaction with acid. If the salt is insoluble, it is prepared by precipitation method. So now in step 3, we can choose the precipitation method since barium sulfate is insoluble in water. So this precipitation method involves reacting two solutions to produce the insoluble salt. Next, we identify the reactants. In this step, we chose barium nitrate and sodium sulfate as both are soluble salts, which will produce barium sulfate, which is insoluble, and sodium nitrate, which is soluble. So now we move on to qualitative analysis. So what is qualitative analysis? It is the process to identify cations and anions. So first, let us identify cations. So to do so, we will need to test for cations. We will start off with a salt solution which contains an unknown cations. Next, we will add aqueous sodium hydroxide. If white precipitate is formed, the possible ions are calcium, aluminum, lead-2, and zinc. So one way to remember them is CAPS, which is C, A, P, Z. So when you add excess sodium hydroxide, only aluminum, lead-2, and zinc will dissolve, and calcium remain as insoluble salt. You can remember this by striking out the first letter C as shown in the diagram. If you obtain blue precipitate, it will be copper-2 ions. If you obtain green precipitate, it will be iron-2 ions. And if you obtain reddish-brown precipitate, it will be iron-3 ions. Lastly, if there is no precipitate formed, it will be ammonium ions. And ammonia gas will be produced upon heating to give you the confirmation that is ammonium. Next, the next test for cation is to add aqueous ammonia. So if you obtain white precipitate, the possible ions are aluminum, lead-2, and zinc. If you recall, these are the soluble salts in our earlier test with excess sodium hydroxide. When you add excess aqueous ammonia, only zinc will dissolve, while aluminum and lead-2 will remain as insoluble salt. You can remember this by striking out the next two letters as shown in the diagram. Next, similarly, if you obtain blue precipitate, it will be copper-2 ion. One difference is that excess aqueous ammonia is added. The blue precipitate will dissolve to form deep blue solution. If you obtain green precipitate, it will be iron-2 ion. Next, if you obtain reddish-brown precipitate, it will be iron-3 ion. And lastly, if there is no precipitate form, there will be two possibilities. One is calcium, which is the cation that is insoluble in excess aqueous sodium hydroxide, and ammonium. Next, we move on to test for anions. First, we have carbonate. To test for carbonate, we will add dilute acid. So effervescence is observed. We will pass the gas into lime water. If the lime water turns chalky, carbon dioxide gas is produced. Next, to test for nitrate, we will add aqueous sodium hydroxide followed by adding aluminum foil and warm up. Effervescence is observed and the gas produced will turn moist red litmus paper blue. Ammonia gas will be produced. Next, to test for chloride, we will add dilute nitric acid followed by adding aqueous silver nitrate. As we all know by the solubility table, silver nitrate is an insoluble salt, so a white precipitate is formed. Next, we have sulfate. To test for sulfate, we will add dilute nitric acid followed by adding aqueous barium nitrate. As we all know, by the solubility table, barium sulfate is an insoluble salt, so a white precipitate is formed. Lastly, to test for iodide, we will add dilute nitric acid, followed by adding aqueous silver nitrate. A yellow precipitate of silver nitrate is formed. So we have come to the end of our topic on salt. Hope you have learned something today. See you next time. Thank you.